Well, welcome everybody to the second cabin fever of the season. For those of you who don't know me, my name is Katie Lieberman. I'm Herring Gut's newest marine science educator. I started in September. For 25 years, Herring Gut has been educating students and communities about the connections between the ocean, inland waters, and the economy of Maine. So the Cabin Fever series is kind of a lifelong learning sort of thing, so people can come together as community members and just embrace learning and just about different things about aquaculture or the ocean. And before I forget my long list of things to mention, so the next Cabin Fever is on January 23rd at 6 p.m. here at Herring Gut and on Zoom. So that will feature Dr. Charles Rolski of the Shaw Institute. And so they do a lot of research with microplastics. So if that's something you are curious about and want to learn more about, tune in here on Zoom or come in person. And then for this Friday, we will be here for the Light Up St. George. We'll have some hot chocolate and touch tank will be open. And so we'll be here at Herring Gut from 4 to 6 on Friday. And those are the only upcoming events. And it is my pleasure to introduce our very own Dr. Sarah Oktay, our executive director. So Sarah is coming to Herring Gut Coastal Science Center after serving as the executive director for the Center for Coastal Studies located in Provincetown, Massachusetts. So Sarah has spent the last 30 years conducting oceanographic research, teaching, fundraising, and communicating with the public. From 2018 to 2021, she was the director of the strategic engagement for the Natural Reserve System at the University of California, Davis, representing 6 field stations and marine labs in Northern California. Prior to that, she was director of institutional advancement at the Rocky Mountain Biological Laboratory in Gothic, Colorado. She received her bachelor's in marine sciences and a PhD in chemical oceanography from Texas A&M and Galveston. And from 2003 to 2016, she was the executive director of the University of Massachusetts Boston Nantucket Field Station, a marine lab and field station on Nantucket Island. So her research focused on coastal processes, watershed health, pollution transport, and harbor water quality. So after 9/11, she mapped the chemical signatures of the World Trade Center ash and tracked its fingerprints into the Hudson River, which coincidentally discovered hospital waste residues from sewage in New York and New Jersey Harbor. So she's done a lot of cool stuff over the years. So with that, I will let you take the lead.
Okay, thank you so much.
Thank you.
I appreciate it. And I also appreciate West Bay Rotary, who is helping to fund these meetings that we're having. So we just heard last Friday that they were going to provide a little bit of money for us to do these community outreach events. So we really appreciate them. And if you know of anyone that wants to sponsor some of these talks, we would love that. That just helps us buy things like stuff to make soup and all of the sparkling water and make sure that everyone's happy. And I appreciate all of you today. I see a lot of folks here in the room that help us in various ways. We've got members of our advisory council like Jane. We've got members of our board like David there in the back hiding next to Katie. And I appreciate all of you. Many of you also are volunteers for us, and we are a small organization that runs on our volunteers. So we want to say thank you so much for that. There's a lot of things that we could not do without the volunteers in this room. Today, we're going to get a little dissertation, probably enough for an associate's degree in coastal resiliency. I hope that's all right. If you guys need to build up your CV. And as you can see, I am short, so hopefully you can see me above this, but it does make it a little easier for people on Zoom, so they're not looking right up my nose the whole time. So that's the plan for this. Can everyone hear me okay? And you'll also be getting some closed captioning here on the screen for people who are having any difficulties hearing. I'm hoping everyone can hear us online. Thumbs up if you can hear me. Awesome. Thank you very much. And we're recording this. So for people that are interested, we'll send a recording of this to you after the Zoom meeting today. So without further ado, I was on the Conservation Commission on Nantucket for 9 years, and we dealt a lot with coastal resilience and with ways to protect the coast. And now that I'm up here in Maine, I just celebrated my 1-year anniversary here at Herring Gut. There's a lot of things that make life a lot easier here in Maine as far as coastal resiliency, like our rocky coastlines. But as you all recall, back in December 18th of last year and on January 10th and 13th, we had a total of 3 major storms causing close to $1 billion worth of damage. Here at Herring Gut alone, we took about $700,000 to $800,000 worth of damage to our lobster pound and our bait shack. And when you go down to the bait shack, you can see that the water is about this high. We're actually going to be installing some, this high pointing to a 4-foot mark on my body. We're going to be installing some interpretive signs to help people understand when you're here on a nice sunny day in summer, how massive these storms can be, how destructive they can be. Large portions of the Maine coast took quite a bit of damage. Harbor masters' buildings washed offshore. Many docks and piers were destroyed. And thankfully, the state and the federal government have stepped forward. We got a grant for $100,000 to provide some repairs for our lobster pound. But I think it really woke up Mainers as to we're not, exempt from all of the coastal damage that is occurring from other hurricanes that typically maintain most of their damage further south. And with warming sea surface temperatures and more frequent and more strong storms, we're going to be experiencing, unfortunately, more of this type of damage. So we need to rebuild smart. We need to move things as they need to be moved, and we need to be thinking ahead. And to that effect, I'll be talking a little bit about the town's Coastal Resiliency Committee, because we're hoping we can talk a couple of folks into joining that and helping St. George be prepared. And feel free to jump in as I'm speaking. I'm going to be doing some things kind of quickly, but if you have a question as I'm going along, just raise your hand or just blurt it out. You can also save questions until the end. And I'm just covering some of the basics to let people know a little bit about why we are where we are and why we're experiencing what we are experiencing. So you can see the regional oceanographic setting for the Gulf of Maine and for Maine itself is very much controlled by, hopefully you can see my cursor and you might, oh, there you go. So you can see these different currents coming in, the Labrador current and the Nova Scotian current coming in and circulating around here in the upper Gulf of Maine. This all counts as the Gulf of Maine. It's constrained quite a bit by these ledges like the Georges Bank, which turn out to be such a productive area. But there's only a few areas for water to actually exit the Gulf of Maine. So it's very shallow. And we're right near the introduction of a lot of melting glaciers that are creating very cold water that then typically sinks to the seafloor and starts the ocean conveyor belt. So another thing that's controlling why we're so warm is the Gulf Stream. And the Gulf Stream, everyone thinks the Gulf Stream current just goes straight across to Europe, but it meanders, it loops, it oscillates, and it throws off things called warm cold rings and cold core rings. You might have been seeing some of these sea turtles that are getting washed up here. Often they actually get stuck in these warm and cold core rings and get transported all the way up to Nantucket, up to Port Anne, all the way up to Maine. Often they end up being cold stunned. They're coming from warm water and they're showing up in cold water. And they think they had last week about 60 sea turtles stranded from north of New York up to Maine. So it's a fairly common phenomenon.
Were they able to rescue them?
Often they can. All they have to do is slowly warm them up, just like you would a human that has hypothermia. You just slowly put them in cold water and then slowly crank up that temperature. Sea turtles are actually incredibly resilient. Am I not sharing my, it says I'm sharing here. Okay, I can, are you all not seeing this screen?
The Gulf Stream and Labrador current screen, yes.
Yep. Oh, they can see it.
Yes.
Okay. Good. Thank you, James. So this is a real-time animation over several days of that warm current coming through. You can see all the different colors. The purples and blues are very cold, cold water. The lighter turquoises and the greens are very warm water. So you can see how dynamic that is. And if any of you have gotten to go to Europe in the last 200 years, part of the reason that Europe is nice and warm is because this Gulf Stream brings really warm air and warm water to Europe. So it acts as a giant thermostat for the North Atlantic. What's been interesting is that this has been changing over the last few years and faster than scientists anticipated. Most of the oceanographic measurements are all occurring faster than we had predicted 10, 15, 20 years ago. And that's one thing that's a little alarming. Some of this is from biofeedback mechanisms that are greater than we expected. Some of it's from atmospheric forcing changes that are over and above what we thought would happen. So long story short, the Gulf of Maine is getting warmer than at least 97%, closer to 99% of the world's oceans. And there's a variety of reasons for this. The Gulf of Maine Research Institute and Bigelow are both excellent repositories of information and up-to-date science, as is the Island Institute. So while I'm talking about all of this, I'll point you to a lot of other resources. So we're just acting as an educational arm here. So GMRI, which is one of our partners, also confirmed that the Gulf of Maine, GOM, is warming faster than most of the rest of the world. The report says the average sea surface temperature, which is abbreviated as SST in the Gulf in 2023, was 52.6 degrees Fahrenheit. Many of you guys have jumped in the Gulf of Maine on and off throughout your life. That sounds pretty warm. That is the average temperature for the whole 12 months. That shows you how much it's warming in the winter months too, which is even more concerning than how much it's warming in the summer months. So that is a pretty high sea surface temperature. This graph shows about 10 or 15 of the last few years. And here's 2023 here, 2022. I think 2024 is going to be mid-range for here. And it shows all of these temperatures are all below, or I'm sorry, all above. 0 would be the standard temperature. So all of these are hotter than normal. So it's a succession. It's not just a one-off. It's a succession of years where the water is hotter each and every year. This graph, even though it's very graphy, is actually very helpful. So this blue line is showing the Gulf of Maine, and all of these points are different measurements for sea surface temperature. The yellow line is the global ocean, which is showing about 0.3 degrees Fahrenheit increase per decade, where the Gulf of Maine has a almost 0.9 degree Fahrenheit per decade, 3 times faster than the world's ocean. So not just a little bit faster, quite a bit faster. And Dr. Susie Arnold gave an excellent talk last week through the Island Institute that we can also share with you all. And she was presenting really recent information confirming this. So one of the causes for this, and one of the things you learn in introductory oceanography, is the ocean conveyor belt. How does the melting at the poles and all the heat created at the tropics, how does it get dispersed around the whole globe? We have 2 mechanisms that control that. The primary one is this ocean conveyor belt that has this cold water being generated up here near Labrador, right by us. This is the melting seawater. Ice cold water that typically sinks, moves all the way down here, and then comes back up and redistributes that warm water from the tropics. So this is moving water of different densities and temperatures. Cold water is denser than hot water. Salty water is denser than cold water. So if something is cold and fresh, it's going to sit on top of something that is cold and salty. If something is hot and salty, it's going to be denser than fresh and salty. Does that all make sense? We actually teach this with kids with colored water and water right out of the microwave and ice cold water. And it's pretty fascinating. So the oceans are doing exactly what we're teaching children. Yes.
So are you saying that the cold, fresh water off the Greenland is sitting on top of the cold salt water?
It can, but when glaciers actually form, the water underneath it gets saltier. So when you have ice forming, you get cold, salty water that then sinks and starts the beginning of this conveyor belt. When it's really hot, it's going to move up and away. And so you have to have water moving in and water moving out. So what's stopping things is we're getting a whole lot of melting here, and we're getting this cold, fresh water that doesn't want to stink because it's got saltier water underneath it. And so it's starting to flow up and over, and it's disrupting this entire pattern. And it's disrupting it a little bit more than we would expect. And we had excellent evidence of this year that was reported by GMRI and Bigelow that I'll talk about here in a second, where they could see that cold, fresh water sneaking into the Gulf of Maine. So it wasn't going all the way to the ocean floor. It was coming right in on that sill and causing what they're calling a cold freshwater plug of water to come in. So some of these things I've already talked to you. One of the reasons we're so hot too is we're really shallow. So you can recall from a couple of those prior things. See if I can show it here. See this, how shallow all this lighter water is right here? This is all part of what was originally the continental shelf. So remember I said that was really constrained. It's much shallower in the Gulf of Maine. Sorry, I worked in the Gulf of Mexico for 20 years, so I will say that a couple of times. It's much shallower, and so it's easier to heat up the water compared to the world's ocean, which is 4 or 5 miles deep in many places. It's also, sorry. You've also got those drivers of the Labrador Current and the Gulf Stream. So the Gulf Stream is moving up further north, and the Labrador Current is changing its amount of water that it's melting into the system. And so it's changing the circulation in the Gulf of Maine. So it's not allowing that cold water to stick around. It's actually injecting some warmer water at the surface part. That Gulf Stream is a major part of that, and that has been reducing in speed and velocity and changing in direction quite a bit. So scientists have been a little bit alarmed by that. Has anyone here seen the Gulf Stream? You can actually see it if you ever go off of, you've seen it. It's very obvious when you go off of the East Coast. You'll just see this big, giant, sometimes half a mile wide section of really cloudy, sediment-filled, sometimes a lot of different algae water. And it's moving very quickly, and you can actually see it from a boat. So climate models are suggesting that not only is this Gulf Stream going further north, but the cold current is being constrained and becoming weaker, so it's pushing more warm water into the region. And they say that the AMOC, which is the Atlantic Meridian overturning circulation, will weaken over the 21st century, and we're seeing this already. And this is because as the atmosphere warms, the surface ocean beneath it retains more of that heat. So that's changing basically its level of fuel and its movement. We're also getting increases to rainfall and ice melt, which means it's also getting fresher. So all of this ocean water is becoming lighter, and so reducing the sinking of the conveyor belt. One of the things that's most interesting too is we've got this cold water I just mentioned a second ago creeping into the bottom of the Gulf of Maine. The Bigelow has got these long-term buoys, as does NERACOOS, which is the National Environmental Regional Ocean Observing System. There are several buoys going all the way up the coast, all the way from Florida up to Maine. Those are measuring temperature, light penetration, typically salinity. And so they've detected this cold water sneaking in from the Labrador Current that they're calling the cold slug. And this is changing a lot of what's happening closer to the sea floor. So most of the things that we do are from satellites, so we're measuring just the surface ocean. We need to get more and more information throughout the whole water column. That's the only way we can see some of these really big changes. For instance, scientists were looking at this return of cold water through the conveyor belt for many, many years and discovered one year that it was down from 12 miles per hour to 8 miles per hour. They showed this huge slowing of this giant current, which alarmed them, as it should. This happened back in 2021, 2012, this cold water sneaking in. And the very next year, we had a really, really warm spell in 2012 and 2013, which is recorded in this paper that I'll present at the end, the resource for. So we had super cold water, and then we had a really hot season right after that. And that affected blue mussels, that affected lobsters, that affected the prey that right whale all use for food. So it had a lot of effects. So now we're going to switch from basic oceanography. I'm just telling you some of those points so you can start thinking about why is the Gulf of Maine so hot? Why are these storms so severe? I'm going to talk about some of the basics of increased erosion. So many of the consequences of more frequent storms and higher sea levels are more erosion. That's being suffered all over the United States. So sea level is rising. I hope everyone in the room acknowledges that and understands that. A lot of times people forget about thermal expansion. So the fact that salt water and seawater is warmer also makes it take up more space. So warm water takes up more space than cold water. So that also increases the sea level in local areas. So whenever you have warmer seawater, that actually adds on top of just the change in sea level itself. So here's a map from a few years ago, not that long ago, showing areas of the United States that are severely eroding, just eroding a little bit, or relatively stable. And you can see that a large majority of the United States is severely eroding. Some areas, like for instance, where I used to work here in Texas, it's exacerbated because of pumping for oil. So the land is actually sinking. So your sea level rise is even worse because your land is sinking. In the next chart, I'm going to show you where it's better for Alaska, because Alaska is actually bouncing up as it's been relieved from the pressure of glaciers. And for many, many years after the glaciers left Maine, we, the state, bounced back up after that weight was released. So some parts of the United States is not as bad as others, but obviously most United States has an issue with erosion. No, this is a little difficult to see, but obviously the big arrows pointing up, those are all bad. And the blue arrows pointing down are fine. So that is where things are eroding or accreting, and where sea level rise. This is relative sea level rise, and this is the relation of the sea level to what it was prior. And here's exactly what I was talking about with Alaska, where you've got this isostatic rebound from the glaciers going away.
But that in itself is a negative in many ways for wildlife, right, and for the population of indigenous people in Alaska, and having equation, the tundra.
Changing completely, and that's, Steve's bringing up a really good point. Go ahead, Katie.
I have a question.
Yep.
You said, how much higher are the tides you're experiencing now, higher than they were 20 years ago? How many degrees warmer is the ocean near us that has contributed to this?
Yeah, so the tides right now are at least, well, you've got tides and sea level. So your tides are going to right over sea level. So sea level itself is almost a foot higher than it was 100 years ago. And they're predicting by 2050 that it'll be 2 feet taller. And this is the conservative prediction, I think it'll be closer to 3 feet. And by 2100, it can be anywhere from 3 to 4 feet. And so the sea surface temperature right now is about almost 1 full degree warmer. So both of those are contributing. Going back to Steve's question, on top of all this, we have all the PD areas, the tundra melting, it's releasing methane, which is a very powerful greenhouse gas. It's changing exactly how Native people use the environment, how polar bears use the environment. A lot of things depend on glaciers, depend on ice. A lot of that ice is going away. So just because you have relative sea level dropping doesn't mean it's a good thing. A lot of times you have to go further for food. We're seeing that often with whale species and with some of these deep sea species like tuna, where they're having to go further offshore to chase their prey, which is also going offshore because it's just too dang hot close into shore. And so a lot of fish are not all that tolerant of changes in temperature, as we find out in our aquaponics lab all the time. So fish like the temperature that they like. And so when you change it significantly, you change the whole food web. So yeah, there's all kinds of adverse impacts when you change ice. Thanks, Katie. And that's fine just to jump in like that. So, and there's pluses that we are in Maine. We're not in Massachusetts, which is losing like 25% of its beaches. We're not in Florida, which is going to be completely underwater in 200 years. So when you talk about Maine, just be aware we're on a rocky intertidal coast where most of the time when we don't have major storms driven southwest, with southerly winds, we don't have all this damage. But we need to build smarter and stronger. We need to put way more buildings up high. I'm going to be hopefully raising that bait shack 6 feet. So I'm going to build for 2100, not for 2128 or 2028. But so what does Maine stand to lose with sea level rise? So by coastal beaches, we don't have a whole lot of sandy coastal beaches, but we are expected to lose about 43% of them by 2030. So just in a couple of years. And 2/3 of our sand dunes in the state of Maine will be going away. For our intertidal wetlands, which are very similar to salt marshes, but anytime you see these large clam flats, that's one of my concerns is how quickly are those going to get drowned? What happens in salt marshes and clam flats and any areas like that, if they don't get enough sedimentation to keep up with sea level rise, they basically get drowned and they don't operate like they would normally. And that's a big problem with salt marshes up and down the entire East Coast. So a University of Maine analysis suggested this is a huge range, but 28 to 57% of Maine's salt marshes could be gone by the end of the century. That's why one of the smartest things we can do is keep rebuilding and rehabilitating salt marshes.
Why that would be, like salt marshes would be gone.
Just inundated, completely
So
inundated.
they look more, they'll be just underwater.
They'll be underwater and salt marshes have to go through that system where they are above water, below water. Everything that lives in a salt marsh is used to having some dry time, some time to actually absorb oxygen, some time to dig burrows. So you're going to have, and there's drowned salt marshes all up and down the East Coast. If you go off of North Carolina's, off of Florida, you're going to find, miles of salt marshes. Typically though, then that starts getting exposed to more ocean waves, and those ocean waves can start breaking up the sediments because it's not protected by being upshore a little bit. So it's going to eventually completely erode those away. But if you take sediment cores, like if I took a sediment core, probably a mile, not off of here, but let's say a mile off of Shoals or off of northern part of Massachusetts, I would find old salt marshes. You'd find sand, salt marsh, sand. You would find these layers of salt marsh. So it's funny, scientists use these terms to talk about things going away. Sometimes things go away naturally. Sometimes things have gone away for years. But these are things that are protecting our coastal environments. So salt marshes are one of the best protectors for a coastal environment. If salt marshes hadn't been destroyed to the level they were off the coast of New Orleans, Hurricane Katrina wouldn't have been near the problem that it was. Usually, I think it's like every mile of salt marsh absorbs a foot of storm surge. So that's a pretty major protector to have salt marshes. And when we get talking about different ways to build coastally resiliently, rebuilding salt marshes, replanting those, bringing in fine-grained sediments that can grow salt marsh is one way to do it. That's a great question, though. So, and of course, high-risk cities and towns, at least 20 cities and towns in Maine could lose 20 to 30% of their land area, infrastructure, highways, and property. And unfortunately, we are close to the ocean. And as Jane knows, and as I know, and as Aaron knows, we've got several roads that are routinely overtopped now, and that's just going to be more and more frequent. So that's one of the things the Coastal Resiliency Committee is working on, is how do we maintain access to some of our different little islands that have causeways connecting to them. How do we maintain access to the little low mill area? How do we keep these roads open, and how do we rebuild roads so that we can get where we need to go? That'll probably be the biggest challenge for us. Climate change impacts on coastal communities. So I hope you all have been noticing over the last, even in my lifetime, hurricanes have gotten way more extreme, more frequent. Back in the 70s, a major hurricane would be almost negligible now. And the whole reason they're getting stronger is that the ocean's hotter. you've got more fuel in the ocean, so you've got more energy to give these hurricanes, more energy to create that torque, to have shear forces that build up, and it's staying longer and longer. Usually a big hurricane would come along and it would strip the ocean of all that hot water, basically, and all that energy, and you couldn't get another hurricane right after it. And now we're seeing multiple hurricanes, which makes, I was just in South Carolina 2 weeks ago, and also talking to friends in North Carolina, and the amount of damage done by the hurricanes that both of them had was pretty extreme. Mhm.
Sarah, I was just wondering, I don't want to jump ahead of
Yeah.
your talk, but is the reason for the rise in temperature of the oceans essentially human caused pollution?
Absolutely. Yes. Yes. There's always been changes in sea surface temperature and atmospheric temperature for years on end, but we are, and I actually don't have that one graph. I'm assuming everyone knows that, but we are way over and above any temperature changes that have occurred in 400,000 years. So this is for sure caused by greenhouse gases. We're now at what, 430, 440 parts per million. When you and I were children, it was 280 parts per million. That's any person can look at those two numbers and go, that's a lot of carbon dioxide. That's a lot of greenhouse gas going into the atmosphere. And that's not even accounting for methane and other sources. So yeah, it's definitely, there's no doubt in the scientific community at all that this is caused by this human caused. And unfortunately, we already have probably passed the 1.5 Celsius marker. That was most scientists felt like the 1.5 centigrade was the tipping point, and we're already hitting that tipping point. It takes about 100 to 200 years to draw down CO2 from the atmosphere. There are a lot of scientists working on drawdown methods and strategies. You can change soil so that it can absorb CO2. You can plant trees, obviously, to absorb CO2. You can grow algae, you can grow forests, you can grow kelp. There's a lot of ways to reduce CO2, but we are already past the point of not feeling impacts. So, and even if we changed and really did what we said we do in the IPCC and we still are in deep doo-doo, frankly. So if I was paid to advise someone on what to do, I'd say plan on 4 to 5 feet of sea level rise by 2100. I would just say, let's plan for it. And there's so many other things we have to plan for too and protect. I didn't say this was a happy, shiny talk, unfortunately. But I still get up in the morning and most scientists do. So, biological impacts, there are winners and losers. I have a whole separate talk for climate change and biological creatures. Things like blue mussels actually do really well in warmer temperatures, and with higher ocean acidification. We teach a whole set of classes here on how much the ocean is getting more acidic because we're putting all the CO2 in the atmosphere that's getting injected into the ocean. If I run back there and use my soda stream and inject some CO2 into some tap water, it's going to immediately drop in pH. It's exactly what's happening across the entire planet. And some creatures can handle it and others cannot. So that's another big problem for us with kelp, with oysters, with all kinds of creatures that need to have stable pH. We've lowered the pH in the ocean by 0.075 units. That doesn't sound like a lot. That's a whole lot. That's about the equivalent of 50,000 tanker trucks full of hydrochloric acid dumping into the world's oceans. It's significant. That was the equivalent of us learning to use, let's say, 8% less oxygen. It would be a problem. And I talk about them by very, very next bullet. Ocean acidification's effect on shellfish. And then we talked about marshes and eelgrass, inundation, disease, and invasive species thriving. So there's all kinds of other effects that happen. There are creatures coming up. I've just had a friend send me an article about someone who's catching tarpons off of Massachusetts. This is a Florida fish. This used to be a once in a 50-year thing, and now it's becoming a once in every 2 or 3 year thing. So that's a very unusual fish to be catching up here. Other potential effects of sea level rise on coasts, more cheery things, loss of coastal habitats, increased beach bluff and dune marsh erosion, loss of recreational resources. This is one thing municipalities don't often talk about. How many trails are you going to lose? How much beach property are you going to lose that's used by the public for recreation? Saltwater intrusion to well water is actually a really big problem in parts of Nantucket. It's a big problem in Texas. Salt water gets into wells 10, 20, 30 miles inland in Texas. More increased risk to urban infrastructures like we talked about, and human safety. So now we're going to talk a little bit about beach dynamics. This is a beach not too far from here down south. Here you're talking about a recreational area here and riprap right there. I'll speed up a little bit, but in fact, I'm going to grab a drink of water. Or Diet Pepsi. So hopefully you guys know the parts of a beach system, but you've typically got a back berm and a back beach. This is all very stable. You've got your high tide line here and your low tide line here. So that's your intertidal area. In Maine, the intertidal area is owned by the private landowner, but you are allowed to access it if you're fishing, fouling, or navigating. So, and I have the public shoreline access guide right here, if anyone wants to take a look at it.
So you're navigating.
Yes, binoculars, fishing pole. And that's true for most states. That is a public right, that is a public good, that was built in all the way back to the original forming of the United States by white people before. When we landed here, those were laws that were passed all along the East Coast. Often you'll see longshore bars and longshore terraces. Those really do a lot to break down waves. So when you're looking at long-term mitigation things, putting more breakwaters, making sure those longshore bars are healthy, not taking sand from there to nourish beaches, which some southern states do, which is a dumb idea, because you're basically taking armor off and then putting it behind you. And so a lot of municipalities have had increased erosion because they haven't paid attention to where they're getting their nourishment sand from. Most of you guys know what longshore drift is, but just in case you don't, when you look at any kind of a beach or shore or coastline, it's all a living creature. All of that sand moves up and down, or rocks material moves up and down the coast. If you put something that stops that movement, you can starve down drift beaches. So you have to be very careful that you don't hurt other people when you're trying to protect your land. Grain size is really important. In a perfect world, if you put me on any beach in the world and I was blindfolded and I reached down and I grabbed the sand or the cobble or the rocks, I could tell you almost immediately what kind of energy is on that beach. If you're in Hawaii, you've got very fine sugar sand. You can tell that you're at low waves that are close to shore, just a small tidal range, and a lot of coral has contributed to the material. If you're here in Maine, you can tell that we have a high energy environment because we have very rocky beaches.
Sarah, there was another question.
Sure.
We just wanted some clarification on access. So this question is, did you say landowners along the ocean own to the levee side of Maine?
Yes. Which is the opposite. Some other states, you only own down to the high tide mark. So I believe Massachusetts is just down to the high tide. Yeah. Delaware is also, I think it's a mishmash. Maine is pretty restrictive on that when you think about that. And where does that matter for us? So when it comes to coastal resiliency projects, whose responsibility is it? So that's always an important thing when you're talking to people that live in the coastal area. Sometimes it helps to give away an easement in order to basically buy protection. So there's times when, and there's access point issues that are always very important when you're talking about ferries, when you're talking about emergency access. So it gets kind of complicated. One of the things we did on Nantucket is went to great lengths to preserve public right-of-ways. Sometimes there'll be paper roads that go straight to the beach, and those get lost in deeds and stuff. And so we had a whole committee designed just to maintain those paper roads and public access.
lost in the woods.
Yes, I'm putting, yeah. Took me a while to come up with that word.
Can I ask a question about the one, 2 slides ago?
Sure.
We have like 350 feet of ocean front, and the question was, should we be moving some boulders, up, because we did lose a lot of our land, our ocean front. So, can we go to our low tide area, grab those boulders and pull them up, to just kind of line them up along at least 200 of the 350 feet? And will that cause a problem for our neighbors?
It can, and I'm actually going to get to that in 3 or 4 slides. There's pluses and minuses. You are building up riprap using your own property. The only problem with riprap is that it often causes a pick point for waves to actually dig out from underneath it. So in some cases, it'll hold up well. In other cases, it makes things worse. But if you're moving riprap and large boulders from the beach and putting it up higher, that shouldn't impede the majority of sand going down to your downdrift neighbors. But you're going to want to work with your neighbors and see how big their beach is. And if you see differences in how much dry beach they have, then you need to work with them to remediate that. So it's kind of a yes/no situation. And I have a couple of slides here that'll talk about it a little bit more, James. It's a really good question. And each one's different, so it depends on what direction you're facing and how your long-term current is going. Does that work for now? And then we can chat about more in a bit?
Yeah, that's excellent. Thank you.
And I'm happy to chat about anything along this line to a greater extent with people. I've been doing that for about 20 years. So quickly, I'll do this. So beaches exposed to high energy waves tend to be steeper. Beaches exposed to low energy waves are not as steep, and they have finer grains. And all the creatures that live on that beach have adapted to the grain size. So one problem I had with people who wanted to bring in large amounts of beach nourishment, usually when engineers do that, they want to bring really large pieces of sand because that will stay longer, but they're changing the morphology of the beach. And so mole crabs and other crabs that live in the beach area are adapted to that finer sand. So you're actually doing a take of that beach by changing the habitat. And for an engineer, it's like, well, sand is sand. And it's like, no, sand is very different around the world. And these creatures have adapted to living in this. Most creatures can handle being inundated immediately with like 1.5 feet of sand. Up to 3 feet of sand tends to completely kill a beach. A lot of those moles and mole crabs and amphipods and isopods and all the creatures that live in the sand can't burrow up through 3 feet of nourishment. So thankfully, Maine is pretty lucky. We've got very rocky coasts. We've got a lot of basalt and very hard rock and flint. Our weathering and erosion have worn away at the land, but we've got these nice rocky cliffs. They're tectonic, typically landforms, which tend to be way more resilient. Bedrock can be seen close to the surface in many parts of the coast. And most of our beaches are rocky. So I would have even thought moving here, and I did think about where I live, that this would be a pretty safe state to be in. But I think last January kind of belied that, because there are all these narrow areas from when the glacier retreated. We have all these Finger Lakes or very thin, small coves. When water and storm surge is driven up there through a southerly, it's really driven up there. And so when you think about it, it's forming basically a funnel for high storm surge. Bless you. So this is just a quick slide showing the last few glacial interludes. The big one that was most recent here was about 10,000 to 11,000 years ago. When you talk about how that changed our coastal areas 10 or 11,000 years ago, you could walk to Nantucket. It was 26 miles offshore. So the Wampanoags just walked there. A lot of these little islands, thousands, we could just walk to here in Maine, because the seashore was way the heck out, all the way, close to where the ledges are. So a lot of people, that's the best way to describe that 400 or 500 feet difference in sea level from glaciers being here and not being here. And I'm just talking about the Laurentide ice sheet, Wisconsin era. And you can see when the ice is maximum, the global sea level is lower and vice versa. We could do a whole class just to that. So how do we mitigate or adapt to these swells and these? So James, first thing I'm going to talk about is riprap. So this is Winthrop Beach in Massachusetts. Many parts in Massachusetts and in Maine and in Connecticut and other areas have been using riprap. Riprap is better than seawalls. I'll have a couple of slides later on that talk about the whole spectrum of sea level rise protection. Seawall is the most dire, the strongest protection, and there's a seawall right here to the right of this riprap. So Galveston has a 28-mile seawall. Galveston in the storm of 1900 had overtopping of about 9 to 12 feet for the whole island. They raised the entire island 9 to 12 feet. Seawalls do stop the ocean, but you don't have any beach in front of it. Here, this riprap is in front of it. Riprap will hold the line, but it acts as a pick point for waves to get underneath it. And so often it'll get undermined. And so that is one problem with riprap, but riprap does absorb the energy better than a hard wall. And you can just think about the physics. Hitting a hard wall, it's going to bounce right off. Hitting riprap, some of those waves are going to go down and around. So here's the progress. If you put in a wall, here's a regular beach. Waves bounce off and they start eroding the beach. And within 20 to 40 years, if you have a seawall, you're not going to have a beach. And then you have to rebuild behind that and build bigger seawalls. They do in areas where you've got airports, sewage beds, they do stop most of the erosion, but they also lose the beach. Here's an example of, you can see from the longshore drift is from top to bottom. So this is the direction of the drift. And so it's accumulating on the sides of these groins. That's the official name for these. There are, gosh, I think 6,000 or 7,000 groins in Massachusetts. Each state actually has a list of all of these coastal engineering structures. They do help, but you can see how it's starving the downdrift area. See that scallop edge? You can really see when you start, there's a couple of great examples on Nantucket of people who built illegally groins, and both of their neighbors have lost like 100 feet of beach on either side of them. And so this is actually the process, and this is the movement of the sand. What coastal engineers are pushing more lately, because it works in many situations, is building breakwaters and building these things right here. So having a breakwater actually breaks the waves before it reaches your beach. So it makes a lot of sense. And as long as you are not affecting migration of fish or whales, they can be super helpful. And you can do permanent ones. You can do riprap here and then have a pocket beach behind it. It's the beginning of a way to actually create a mini harbor. You see a very famous jetty when you go out to Rockland. That jetty keeps that ability to get around and into the harbor. Jetties are usually built to keep a channel open, and that protects all of Rockland Harbor, right? So it's been there a long, long time. It would be very interesting if you pulled out that jetty, you'd have a lot bigger storms and waves, but you also would have a lot of sedimentation up in the harbor. So they're typically created for channels for boat passage. And most of the time they have to be, typically you have to do some dredging around them. They normally extend past the breaker zone. One thing I had to do on the Coastal Resiliency Committee on Nantucket is we have one major set of jetties. That's the only way to get in town. If there's a large boat that sinks in the middle of that, that shuts off all access to the entire island. So we actually looked at other parts of the island to bring amphibious craft, to bring in oil and people. So if you do have a single set of jetties into a single port, you are limiting your public access. So here's that quick thing showing living shorelines all the way to coastal structures. This is that spectrum I was talking to you about, from greener to softer methods to gray or harder techniques. And different techniques work in different areas. So not, it'd be great if, you could just add vegetation, it'd be good, but usually it takes a variety of things built together. before you hopefully avoid some of these more dire structures. Got a couple more examples of living shorelines. Here's a regular shoreline where the bank is undercutting. There's sediment in the water. A living shoreline, you would put in a core log, you might put in some oyster shells, build an oyster reef, plant kelp. The fact that we're losing kelp is reducing probably 60% of the wave attenuation reaching our beaches. So even having large scale kelp regrowing methods would be helpful. I'm not against harvesting kelp. I think it's a great way to augment fishing, but you need to do it thoughtfully so you're not removing protection underwater. And then building a marsh up here always is helpful. Here's from NOAA showing a whole series of things from seawalls to living shorelines. Oop, went fast, but I probably need to pick it up. And like I said, I'll provide all of this to you. Here's a place I was not too far from in Beaufort, North Carolina. Here is a living shoreline. They've got a little breakwater started off here with oyster reefs. Let me tell you, oysters are one of the best things. The more we can support oyster reefs, they help mitigate ocean acidification. They help provide food for fish and for us. And they really do a great job of breaking wave energy. So any place that you can safely put in oysters, and they clean the water. So I can't think of anything off the top of my head except maybe eelgrass that is more effective for reducing wave energy. And in this case, they built a big marsh, and you can see this is a built environment. It's behind a breakwater here. It's behind a barrier beach, but with sea level rise, they'd be in deep doo-doo on this in this area. They've got, and even docks like this, docks are fine, but docks also change the erosion profile underneath them. This is where I used to live. This is looking out my second story window during Hurricane Sandy on Nantucket. That is a harbor. This was a salt marsh. That was a 20-foot tall barrier beach that got overran in Hurricane Sandy, which was not a bad hurricane for Massachusetts. So these barrier beaches are very, very helpful at protecting back beaches. This is all sand and terrain there. So the town of St. George is way ahead of the game. They are doing an awful lot to protect us. We have a sea level committee. We've got a coastal resiliency committee. We've got a partnership. We have this resiliency project where we're collecting information from the community. We're working on road repairs, and we're looking at elevation and pedestrian access. So these are all, I'm very impressed with the town of St. George for such a small municipality, way ahead of the game. So this is what the St. George website looks like for sea level and resilience. It's a lot of great resources. I'm going to walk you through some of it. A couple of years ago, they paid Sebago Techniques about $50,000 to do $150,000 worth of work. They used LiDAR to a millimeter level, which is a type of laser, reflective laser mapping technique, to actually map very accurately most of St. George. And the reason why that's helpful is we need to know where sea level rise is going to occur, and it's not always the most obvious location. So you can go onto these sites and actually look here in the town for free and get these maps and do some scenario planning of your own. Look at a 1 foot rise in sea level, then add 2 feet of storm surge, which is common on top of that, and see what areas may be in trouble and what aren't. So this is a couple of areas not far from us and me running a few different scenarios. I'm cranking up a little bit faster because I'm almost out of time. Here's 2 different areas where we're a big concern. This is the highest astronomical tide in 2018, plus 3.9 feet of sea level rise or 6.1 feet of sea level rise. So let's say by 2100, this 3.9 is definitely, is definitely going to be an issue. So these are 2 areas that we have to find solutions for. Here's a list of all the roads that the town is reviewing and is put on a priority list. Certainly there are several that we can take care of as a town. If it is a state road, it's on the state's priority list. And if it's private, then the best we can do is meet with those homeowners and try to figure out what kind of possible funding they can find or how they can develop a resiliency plan. This is also really impressive that the town has already figured out what roads need help and when do they need help. So here's the data collection and assessment network. So this is in collaboration with the Knox County Emergency Management System. This is a GIS program that you can find through the town of St. George. And this shows each of our different areas. And here is, in fact, we were looking where we're at because I'm having to figure out how to be coastally resilient here for herring guts. So we're looking to see what the different scenarios are with sea level rise there. Here's another area. In another way, almost all coastal areas and municipalities have some type of viewer. One of my take-home messages for people is if you live in any coastal town up and down the East Coast, not all of them, but about half of them have a sea level rise viewer. And FEMA also provides one for the entire United States, which takes into account rivers and wetlands. So there are quite a few out there. So we have a decision matrix for shoreline resiliency and prioritizing projects. Normally it's how many people are going to be affected. Is there anything you could do? Is there something where you can build higher? Is there a natural protection nearby? And at the very worst, is it an area where you have to retreat or abandon it? And there are places where you've just got to retreat. And retreat in this way doesn't mean just us running away from the water. It means picking up buildings and moving them. So one of the alternatives I'm looking at for the bait shack, which you're all are welcome to go down and check out, is picking it up and moving it further back on our property. So that would be a permanent solution versus 6 feet up, hopefully is a permanent solution too. Here is what many municipalities do, and this is called a Relative Coastal Vulnerability Act mapping, and it shows each of these colored bars represents things like storm surge, accessibility, wave height, shoreline change, and geomorphology. So there's a few for Maine being done right now. So options here, natural hardening, structural hardening, shoreline protection, diverting water runoff. That's one mistake people often make. They build riprap or a seawall and they do not, and this is my concern actually down the street, Jane, is not diverting the water runoff properly. And if you don't actually have built-in swales to collect storm water, especially water that comes up and over and then has no way to get out, sometimes you actually push your own wall down from behind or end up eroding it on either side. So a lot of people don't think about water runoff and how to protect from that. Most of the time, if you can leave natural shoreline vegetation, if you have trees, I would definitely leave trees in unless it's an immediate danger to your home, because the trees are doing a really great job of holding the line. Sometimes you can install riprap. That is much better than seawalls. And if you do it carefully, you can do it in a way that's not too onerous. I'm going to provide this to all of you. This is maps at coastalresilience.org for Maine. This is also really helpful. This is a state site. And once again, there are scenarios for current sea level, 1 foot rise, 2 foot rise. That does not include storm surge. That is just simple math there. It's another version of that. What I really like about this is it's actually showing how many houses are affected, what's the cost of recovery, timeframes, how far you'd have to go up. Next, last slide. This is a living shoreline installation in Casco Bay. I just wanted to include it so you could see what one looks like. And it could be worse. This is where I was on the Concom working with this erosion there on Nantucket. And then our resources. And that's it. Kind of sped through the important part probably, but
Sarah,
yeah.
can you just let people know where the town is with our development of a climate action plan, sort of the next step from the Sebago work?
And Aaron can probably do that better than I can.
Well, I just got involved, so I'm a little bit behind on learning about it, but I know there's been a grant submitted for. I think involves a lot of surveying and trying to figure out where to prioritize. And I think we're working with the town of South Thomaston as well to work on that. So it's a lot of collaboration as well. Yeah, that'll be my next one.
Yep. So thankfully, we've got Aaron here as an island fellow, and I'm very grateful to them for being here. So there is an initial climate action plan that's already been written, and now we're upgrading that for something more comprehensive and looking at everything from solar panels to access sites. Aaron's going to be helping with some of that. A lot of it's going to involve public outreach. And so they've got our request for proposals out to share a position with South Thomaston, because a plan is no good unless people know about it. And I'm sorry I rushed through these last 4 or 5 slides, but that's the big take home message that I want you guys to do when you go home. And when we send you the link to the PowerPoint and to the Zoom talk, is that look at all of these different things that we're doing as a town. Look at your street, start making decisions on what you may or may not need to do, and kind of get informed on what's available out there. As far as, and a lot of these are followed up with, you know, with advice, with groups to talk to for rebuilding. Certainly for St. George, you know, the 2 access points, we're looking at what's happening at Drift In Beach, what's happening over at Mill Pond, at the co-op's already under control, but what's happening with the general store? How is that rebuilding going to affect things? How do we access the ferries? There's a couple of locations, I think off of 73, their little Turkey Cove has got a low point. And how do we give advice to folks that are at like Scrabble Rock and stuff, you know, these islands? Yes. Yeah, different causeways and stuff like that. I'm actually pretty shocked that there's still causeways, though honestly, a causeway if designed well is pretty effective to actually just deal with sea level rise by letting things get overtopped. Often works better than trying to build something to keep the ocean from getting on top of the road. Sometimes you rebuild with nature, it actually is better than building against it. So you could argue that causeways are actually not a bad idea. Those can be raised, but making sure that they still can absorb water down and through it instead of making it too impermeable. Impermeable substances are a death knell for coastal resilience.
Well, and that's something I want to ask you about, because I'm wondering whether the state of Maine is getting updated advice about this, because when the select board heard from engineers last September, a year ago, September, on advice for remediation on Drift Beach Road, we were thinking, a lot of us were thinking more big rocks like what we have now, which has historically worked fairly well there. You just go scrape off the debris a couple times a year on the storm. But we were told by the engineers that the state would require a cement wall, which, you know, so that's one of the challenges is, I think the science and the advice is changing, and even if engineers would agree there's a better way, if the state requires a different way, then, you know, we made a different choice there, just make a better culvert and have it. I mean, every place, there's so many issues, the easements, the neighbors, and of course, the huge costs of all the remediation that we're thinking about, and where is this money gonna come from? You know, in a town of 2,700 people.
Absolutely.
You know, we're not gonna be able to raise all the roads multiple feet. And one of the big problems we have here is that the biggest choke points for traffic on the whole peninsula are on state roads. So in front of Wildcat and near the Mill Pond on 131, all we can do is advocate with the state to get them to pay attention to places that went, and we had time last year when that big truck of rocks came down in front of the busy daycare or whatever, and the whole peninsula, nobody could go anywhere for hours. So it's a challenge that we're dependent on the state to deal with the state roads. And the other challenges, gotta raise some money to the town roads.
Well, and when it comes to when you do alternatives analysis, even if it's really expensive now, if you do it once, and most of the time I would advocate raising a road, even putting a concrete bridge basically, and allowing more water to come underneath. You've got a lot of areas where you've got constrained wetlands, both freshwater and saltwater behind. So you've got to take actually there where you've got habitat loss, even with drift-in beach, you could argue putting in some really nice culverts, repairing some of that marshland behind there and putting either ending it as a dead end on both sides, which I know is one of the things the Resiliency Committee is considering, making sure everyone has access to their home, but maybe not a straight through access. Or having something that goes up and above and allows as much water as possible to go underneath. Usually when you put in a hard structure, it's going to find a way to tear that up. So doing an alternatives analysis that says, well, it might be 2 million to put in the Cadillac plan, but we wouldn't be repeating it every 3 years. So you could actually do the, get some scenarios set up for, let's say it only cost 100,000 to repair it, but you'd have to do that 10 times. Then you start getting to a cost benefit analysis that makes sense. The good thing for Maine is it's got a lot of great groups like Island Institute, Bigelow, GMRI, that are doing incredible research and know better. I think our administration and governors on top of things, but Massachusetts is probably ahead of the game as far as their Division of Marine Resources being very aware and having very strict regulations. I don't know I haven't read the whole state's wetland regs or the local, I know them very well from Maine, but I'm not aware of what they are here. In Massachusetts, you're very limited. You can't protect any post 78 home with anything more strenuous than what's already there. So if you have major changes to a home, even if it existed before 1978, if you really upgraded your home, then you lose the protection for something like a seawall or riprap's not. No coastal engineering structures are allowed in Massachusetts for any pre-78 homes or any homes that have been significantly upgraded that are existed before that. So I don't think it's nearly as strict here in Maine. And part of it's because it's a rocky coast and a lot of these problems are somewhat new. I'm surprised at how many things in Maine were rebuilt right in place, where I would think in other states it'd be mandated to bring it up 2 feet. So that's a really good question. I should get more informed on what the state regulations are and where they're heading, and where they should be heading.
The Wildcat coping.
Mm-hmm.
I think that was volunteer, the amount that he raised.
That was probably appropriate. Well, I mean, if any structure should ever exist there to begin with.
But I think some places the general store is being required to go up 2 feet.
2 feet,
But
yes.
they're choosing to go up 3 feet
Mm-hmm.
in hopes of that being more protected.
Yes, they should absolutely go up 3 feet or 4 or 5.
But then it's got to match the road, so
Yeah.
that's where we're gonna mix right now. the town
Right,
trying
the
to
town and that
make that work.
yeah, and that's gonna be a problem point for that. Do we have any more questions online?
I do. This is Jim. You had mentioned like some real good things would be like eelgrass, oysters, kelp. Is that something like more for municipal, or can Jim, the homeowner,
Homeowners
I
do
wouldn't
that
even know
all-
how to begin. Mhm.
Homeowners, I mean, like I said, I've only been in this state for a year. In Massachusetts, homeowners go to an engineer and say, I do want, like a salt marsh installed, or I want eelgrass. You can, just like you can order concrete and gravel, you can order remediation done from, vegetative experts, and there are thousands of them in New York State. I mean, New York State's actually a really interesting area to see how they rebuilt after Sandy and how municipalities and private homeowners. But that's a service we could try to hunt down for you, Jim, is that here at Herring Gut, we can contact folks and see if there are folks that are doing that. That's a big industry. Like I said, in Massachusetts, a huge industry of engineers that get paid to put in these living shorelines. So it's not only done by municipalities because people have those same issues. Jeff Schroeder might know people that. Certainly an oyster you could talk to. This might be a good side gig for someone that does musseling or oyster work, is whether they would be able to build an oyster reef in front of your property, small breakwaters, You do have to get a permit for anything that's under the ocean because that is a public right of way, basically, but I think it's possible.
Yeah, and again, do you need to get a permit for stuff that's that you can get during mid or low tide? That there's no water on it?
I've got 3 Concomers in the room here. I know I know the answer for Mass, but what's the answer for Maine, or does anyone want to go on the record? We've got 3 people that have been on the Conservation Commission here for 20 years.
I mean, everybody's been doing such emergency measures
Yeah.
last year, you know, all around, and it was like crazy. But what's the right thing to do, you know? And
Yeah.
yeah.
Ingrid, what do you think?
Well, I think I'd have to look at that up. I know that for shoreline stabilization, there is guidance both from the state, and I was actually looking to see if we had an ordinance, and I'm not sure. But there is guidance as to what percentage of your property line you can do anything to, without seeking, you know, permit. And it's not a lot, so I,
Yeah.
anybody looking to do things on their shoreline should get in touch with Terry Driscoll, you know, the code enforcement.
Yeah,
officer.
so-
Brackett, excuse me,
Yep.
officers.
Terry Brackett, yeah.
Code enforcement officer, and see, just because I've heard of so many people doing so much without doing that.
Yep,
And as you mentioned, one of the benefits to that, I mean, of course, it can be onerous. We put in a little set of steps that we have to go through the town and the DEP. For, I mean, I think there's not even 6 steps and it's above the high water mark. And
mhm,
so I know that what you mentioned, what is it to the neighbors? Because once you start doing things and is what you're doing helpful? We know some people that did a lot of work with bringing in rocks and things, and they just put rocks, but those rocks are just gonna get moved,
right.
right? And so it's in part to protect the neighbors, it's in part to protect the environment, it's in part to make sure what you're doing is useful.
Yes, and I agree 100% with everything Ingrid was saying on Nantucket. A lot of what we did was protect people from themselves. Sometimes they would put in like beach stairs that would do nothing but form a really bad erosion point, and they'd be undermined within 6 months and have to be rebuilt. So there's a couple of things to typically a Conservation Commission requires permits for anything within 75 or 100 feet of a wetland. But you can talk to Terry Brackett. I mean, it depends on what has existed before. If you're bringing things back to the way it was before, then it's not considered new work. So there's a lot of specifics on there that you want to chat with him about. Definitely look at the town's Conservation Commission website. There should be guidance there. There's state guidance. I'm sure there's folks here in the room to be happy to walk out there and chat with you. But you know, when you are doing work in or near wetland, often you have to have some amount of permitting. And my experience here in Maine is that is not as rigorous as it is in other states.
The shoreline zone rules are fairly strict.
Yeah,
I mean, the St. George basically adopted the state regulations for the most part. We have a stricter regulation. for the
Correct.
town, but we cannot be more lenient.
Yep.
Than the state and.
yeah,
So in general, that the state. rules.
yes. So did you hear, I'm not sure if you could hear that, Jim, but Jane Conrad's here and she was saying the town adopted the state regulations. So you should be able to find those online. You
And
can,
they're on the town's website.
and they're on the town's website. So maybe check it out and feel free to give us here a call and I can always help try to connect you. Under the land use ordinance. Thank you. That's super helpful.
I thought I'd also mention real quick that there's actually a group of Casco Bay that's restoring the grass as a pilot project, so there was a recent Herald article about it, and I dropped it in the chat for the student participants.
Nice. And I showed that slide at the very end, the Casco Bay slide of their living shoreline.
Yeah, I was thinking that would be a great talk, future talk.
Yeah,
Of things that private homeowners or the town could encourage as far as eelgrass and oysters,
sure.
all that stuff. That would be very interesting.
Well, and if you can sometimes even get paid for habitat restoration, and there's different types of grant. If you're actually restoring a private or prior habitat, So that's another way to look at coastal resiliency is, are there different pots of money for helping the state overall provide more habitat for shellfish, for eelgrass? Those are all positive improvements that typically are different types of funding available. And oysters. Oysters are about the only thing that's going to save us, actually. Do we have any more questions online?
We're so lucky to have you here.
Oh,
Sarah.
you're very sweet. Thank you. Thank you, guys. Thank you. That's very sweet. I'm gonna
This
stop.
has been excellent, excellent.
Oh, my pleasure.
Thank you.
Thank you.
We're gonna stop the share, stop